Hello ctrlX fans. This video provides an overview of the Vertical Form Fill Seal template for ctrlX Core. Vertical Form Fill Seal is a packaging application in which food or other product is deposited from a hopper into a continuous flow of packaging material such as foil or plastic. Heated seal bars close in on the material to form a seal. Each seal closes the top of the last bag and forms the bottom of the next bag. The seal bars are controlled by a horizontal axis, sometimes referred to as the jaws, which open and close. Since it's a continuous process, a vertical axis is required to synchronize the jaws to the material while the seal is being formed, and then return to the top for the next seal. This motion is achieved using Flex Profile. Flex Profile is a form of electronic camming with special features that lend itself to this application. For example, a Flex Profile segment can be synchronized to master position and/or have a time-based component. This allows us to create a profile which stays synchronized to the web while the seal is being made, and hold sealing time constant as the profile adapts on the fly to changes in machine speed. The template includes an axis configuration for ctrlX motion, a PLC project using a PackML programming structure, and a web-based HMI using WebIQ. It also includes a 3D visualization of the Vertical Form Fill Seal application. The 3D model is animated based on the position feedback of the axes. This allows the user to visualize the process without needing any physical drives or machinery present. Using this template reduces the burden on the user to have to develop the application from scratch. Included in the template package is this image of a virtual ctrlX core that has everything that's needed for the template preloaded on it. And this how-to guide tells you how to set up and run the virtual ctrlX core. And then run the application. This allows you to test the motion, PLC, and HMI without needing any hardware and without needing any software licenses. A free download of ctrlX Works is all that is required. Also included is the PLC project that can be opened up in ctrlX PLC Engineering. And the WebIQ HMI project. And the app data archive, which could be loaded to a ctrlX core. The app data includes the EtherCAT and motion configurations along with the compiled PLC project. This is the dashboard of a ctrlX core that is running the Vertical Form Fill Seal template. Let's take a look at the apps and licenses that are involved. If you only want to run this on the virtual ctrlX core to evaluate it, then you don't need any licenses. All the apps on a virtual ctrlX core will work for 4 hours of runtime, and after that point you can stop and restart the virtual machine to get 4 more hours. But I'll point out the licenses that are needed if you want to run this on a physical ctrlX core. So we have the motion app, and with that one you'll need the motion standard 4-axis plus an additional add-on axis because 5 axes are used for this application, or a motion standard 10-axis would work. You'll also need 3 add-on licenses for motion. 1 for electronic gearing, 1 for camming, and 1 for Flex Profile. And then for the PLC, you need the PLC Basic and Standard licenses. and that's for PLC version 02. And then the WebIQ server app, that's for running the web-based HMI project, and you need the 500 tag version of that or higher. EtherCAT master will be needed when you get to the point of connecting the axes in motion to physical drives to actually run a machine, and so this requires an EtherCAT master license. The 3D viewer app is used to visualize the CAD model of the machine and animate it in real time while the machine is running, so that requires a license. OPC UA server is needed to connect the WebIQ application to the ctrlX core, so that needs a license. The oscilloscope app is just an optional app for diagnostics and troubleshooting to be able to trace signals in the motion and PLC, but that is not needed to run this template. And the Core 20 is just a system app that's needed for WebIQ to run. This app does not require any license. From the ctrlX core dashboard, we can go to the 3D viewer app. And so this is the CAD model of a vertical form fill seal machine. And we've got these two belt axes that are pulling the packaging material down through the machine. So these are the seal bars, and the horizontal axis, which is referred to as the jaws, are going to close in to make a seal and open up when the seal is finished. And then there's a vertical axis to synchronize the seal bars to the material while the seal is being made. So let's look at the axes that are configured in the Motion app. The master axis is a virtual master that's used to synchronize the motion of the other axes as the bags are being made. One revolution of the master axis represents one machine cycle, or one bag. The belt axes draw the packaging material through the machine, and these run in position synchronization to the master axis. There's the jaw axis that controls the horizontal open and closing motion of the seal bars, and then the vertical axis for the vertical motion of the seal bars. Let's open up the HMI so we can run the machine. The username and password is Bosch Rexroth1. And then we'll go to HMI projects and then open. The 3D viewer is embedded into the HMI along with a visualization of the PackML state machine. After the ctrlX core boots up, we have to click clear twice to get it into the idle state. And then start to get into the execute state. When we're in the PackML mode automatic and the state is execute, that means the machine is producing products. There's also a manual mode which allows you to slowly jog the machine in a synchronized fashion, which you might need to do as you're setting up the machine, and a maintenance mode which allows independent jogging of the axes during machine commissioning and maintenance. Let's go back to the machine overview. So here we can see a visual representation of the bags being sealed after the product has been deposited. Notice how the seal bars match the speed of the product as they close and make the seal. As we increase the products per minute, the seal bars will stay closed for a longer vertical distance as the seal time is kept constant. And we can view the operation from various angles and zoom in and out. If we look at the axis status while it's running, we'll see that the belt axes are in synchronized motion, as is the vertical axis that's running the flex profile. The jaw axis will toggle between standstill and discrete motion. The jaw can be handled either with a flex profile or with discrete motion, meaning positioning moves to the open and closed positions. And in this version of the template, it is handled with discrete motion. And then the master axis is running in continuous motion. Let's take a look at the data layer. These are the variables in the PLC project that have been added to the symbol configuration so that they're available on the data layer for the HMI or for other applications to access. Some of these have been linked to the WebIQ HMI application, some of them have not yet. Let's take a look, for example, at jaw close time. So this would control the seal time. Right now it's set to 500 milliseconds. So if we take note of the distance traveled while it's closed, and then we change this, let's say to 1,000 milliseconds, you can see the effect that the jaw is now open at a lower position because it remains closed for longer during the downward portion of the flex profile. This is an example of what the flex profile for the vertical axis looks like. Here you see it ramping up to the speed of the web. Here it's in the constant velocity portion of the profile where the sealing would occur. Then decelerate and then return back to the beginning for the next product cycle. Eventually, more functionality is going to be built into the template, including the ability to change the format length or bag length and change the flex profile structure. For example, you could change the starting point and the length of this constant velocity portion where the sealing is going to occur. And then you could store these settings as a recipe and load it later. These features are roughed out here but not implemented in this version of the template. Let's go back to production. A couple more points about this 3D viewer. If you don't like these dimensional lines, you can turn that off by clicking here. And if you click here, you remove everything but the seal bars and the product. Okay, let's stop it. And we'll look at the PackML diagram. When it's stopped, we can switch between these three different modes. So if we go to manual mode and then press the jog, let's press clear to get to idle. And from there we can press the jog enable to get to execute. And then we'll go to the machine overview screen. And now we have these buttons to jog the virtual master. So this allows us to inch the machine along or step it through slowly, as we might need to do when setting up the machine. And then if we look at maintenance mode, now we have buttons to individually jog the axes. For example, here we're just jogging the belts. If you want to change the jog speed, you can go back to the recipe screen and then jog properties. So this kind of functionality could be used for initial commissioning, for maintenance operations, or for clearing a jam, for example. Let's take a look at the PLC project. This uses a PackML programming structure and state machine to control the program flow. It includes some basic logic to execute the motion functions, but can easily be adapted by going to the relevant containers and editing the code. For example, each axis has its own POU with logic divided into actions according to the PackML mode. So for example, if we want to edit the code that is executing for the JAWS when it's in automatic mode, we go to producing. There's a slight difference in the nomenclature between what's shown on the HMI and what it's called here. So automatic mode on the HMI is equivalent to producing here in the PLC project. And so here's the command to close the JAWS. So this is a bit that turns on when the vertical axis has entered into the constant velocity speed match portion of its profile. And so when that turns on, the JAWS is commanded to move to the closed position. And then a timer starts. And when the timer has elapsed, or when we've exited that constant velocity portion of the profile, the JAWS are commanded to open again. One of the other features of Flex Profile is the ability to configure events And so you can configure an event that turns on a PLC bit at the start of the constant velocity segment of the profile. And that way, even if you change the beginning and ending positions of that portion of the profile, this bit is always going to be synchronized to the beginning of that speed match portion where you want the seal to occur. And if we look at producing for the belt drives, here it's getting the command to synchronize to the master with a 1-to-1 electronic gear ratio. If we look at manual, it's going to look very similar because in both cases the belt drives are synchronized to the master, whether we're in producing mode, which is normal machine run, or manual mode, which is jogging the machine in a synchronized fashion. If we go into maintenance mode, we have logic here to jog the belt drives, positive or negative. And so once you orient yourself with the layout of this project and the connection points to the PackML modes and states, you'll be able to add or edit the functionality to suit your needs. Join the ctrlX automation community to find further information and use the forum to post questions and inquire about the vertical form fill seal template and other application templates for ctrlX. Thank you for watching.